right at 1 o'clock, so I'm going to go ahead and kick things off. Okay, for those of you online. All right, welcome everybody. Thank you for attending this session on reverse auctions for procuring environmental benefits. I'm Leah Palm-Forster from the University of Delaware, and I'm going to help with the in-person organization of the session, but our actual session organizer is also our first speaker, and that is Shamanti Banerjee from the University of Nebraska, Lincoln. So we have 4 presenters in this session, and so they're going to have 20 minutes each, and we'll try to keep the presentations to about 17 minutes. To leave 7 would be very short. Shock to everyone. And with 3 minutes for questions. And so I'll show the timers for our speakers at 5 minutes, 2 minutes, and stop. We're going to have every other speaker will be in person, so we'll be going back virtual versus in person. I think that's all of the housekeeping. The only thing is that the virtual speakers and attendees cannot hear questions from the audience. So if you're willing, if you have a question, if you're willing to just run up and ask it into the mic, that would be best. If you're shy about doing that, I will repeat it so that they can hear our questions. All right. So without further ado, I'm going to hand the screen over to Shamanti. So take it away.
Thank you so much, Leah, for introducing the session. Hello, everyone. I am very excited to be presenting this research to you. And by the way, my presentation is on one screen and my camera is on another screen. So there is a possibility that I actually might not be looking at you, but somewhere else. But you know that I'm looking at the slides. I'm very excited to present this research to you. This is very, very preliminary. I've just gotten the data and we have just analyzed it. So I'm really looking forward to getting some reactions from you, because other than, you know, the folks who have been involved in this research, nobody's seen this before. So I'm very excited, you know, for all your feedback in how we can, you know, take the next step in getting this ready for more analysis and publication. Okay. So without further ado, the title of my presentation is about looking at the impact of modification of auction budget spending on conservation auction performance. The title is a little different from what was in the schedule, just because whatever I put in there is so damn long, so to speak. This is joint work with Dr. Mark Conte at the Department of Economics at Fordham University, and we gratefully acknowledge the involvement of these following people in this project, without which I wouldn't be here today. So James Keeler, he is a PhD student at the University of California, Davis, who was instrumental in actually setting up the experimental code. Haneen Hosni and Sabrina Gulab, both graduate students at the University of Nebraska, Lincoln, who collected the data, as well as graduate student participants who participated in the pilot leading up to data collection. And I gratefully acknowledge the funding from USD and NEFA for this project. So as you know, this project, this session is about conservation auctions. So a very brief overview about what these auctions entail. These are reverse auctions or procurement auctions, where the auctioneer, in case the regulatory agency solicits bids from private producers, and these bids are correspond to what it would cost these private producers to implement different land use practices on their properties, right? And the auctions are relevant in this particular setting because of the key feature of asymmetric information within this context, which is that the regulator has a fairly good idea about the environmental benefits associated with the different land use practices that can be implemented on private agricultural property, but they don't know about how much it's going to cost the producers to do so. And on the other side, the producers might have some idea about the magnitude of benefits that would be generated for themselves as well as for society from implementing these practices, but they don't have a very good idea. They don't have a good idea about the benefits, but they have a fairly good idea about how much it's going to cost them to implement these benefits. So given this feature of asymmetric information, auctions have been used in the context of procuring ecosystem services benefits from private agricultural land under different contexts in different parts of the world. So the CRP uses a bidding mechanism. The higher level stewardship scheme in the UK uses bidding mechanisms. And there have been lots of other pilots and programs in countries such as Australia, Germany, China, and elsewhere. But the main challenge that policymakers as well as researchers who are working in this domain have faced is the problem of actually improving the performance of the auction or maintaining the performance of the auction, because these auctions are susceptible to rent seeking, where over time with repeated interactions, the bids that are submitted by these producers pretty much reach the bid caps, which are the price ceilings that exist for these bids in specific locations. And again, as I said, repetition erodes auction performance. So as a result of that, a lot of work in this particular area has dealt with identifying mechanisms and modifications to the auction feature, not only to achieve different types of environmental goals, but also to look at how you can address this cost effectiveness challenge. Okay. So our contribution in this particular literature for this particular study is to specifically focus on the budget that is associated with these conservation auctions. So if you go through these papers, you will see that there is a fixed budget that is used to procure projects, and oftentimes, more often than not, there is some money that's left over. And definitely in the experimental research in this domain, that nothing really happens with that amount of money. But so in that sense, these funds remain unutilized. So that got me kind of thinking about, could we do something with these funds? And that's kind of linked to this other strand of literature, which I had read, which deals with the provision of public goods, specifically threshold public goods, where this cited paper by Marks and Crossan in the Journal of Public Economics in 1998, what they find is that when they are looking at looking at private contributions towards generating a threshold public goods game, if they tell the experimental participants that whatever contributions are made beyond the threshold, so whatever is left over after reaching the threshold to generate the public goods game, those funds will be redistributed, will be used to produce public goods, which will again be generated, which will be enjoyed by the participants who contribute to the threshold public goods game. Threshold public goods. And this is the utilization rebate mechanism within the threshold public goods game literature. Again, to repeat, what they did was that they promised that whatever money would be left over after providing the threshold public goods would be used to provide a different public good, which would be enjoyed by the contributors to the threshold public good. And the way they motivate this particular design feature is by giving an example of a utility in the city of Buffalo in upstate New York, which did this kind of utilization rebate feature and found that the total amount of contributions to public goods went up. So taking this particular component, the utilization rebate mechanism, what we do in this particular study is we look at whether that remaining budget, if you will, which I talked about in these auctions, whether that budget can be utilized, if you will, to improve the performance of these auctions. And I will talk about how we measure the improved performance. And we do that, and while we do that, we additionally look at two features of the auction, which is that what is the role of information about environmental benefits provided to auction participants on the performance of the auction, and what is the impact of community identity or generating community identity on auction performance. And the reasons for looking at these two features are many. So first of all, again, as I always say, is that I am a big proponent, and I'm sure everybody else is, who does experimental research, is to focus on treatments where there is compelling evidence for the treatment going one way or the other, right? So in the case of conservation auctions and information, the evidence is really mixed about what role auctions information in these auctions can play. So these are auctions which are very, very complicated, and information can facilitate bid preparation, right, as is what we find in our own research, which was published in 2018. But at the same time, research by Dr. Tongsi Lee, who is in the audience and will be presenting her work, and Messer et al. In 2017, what they find is that, providing information can actually negatively impact outcomes under some settings and not in others. So that is why it made sense to us to look at the role of information, providing information in the context of this new auction format. And I'm going to talk about what kind of, so the information that we are looking at is providing information about the environmental benefits of the project. Okay. The other is the role of community identity. And why are we interested in this? We are interested in this because building group identity. We know that agricultural communities, most of them are quite well knit, giving rise to lots of, social capital and trust within the community. And that can maybe trigger what we thought altruistic tendencies towards these losing bidders who can get money as part of this utilization scheme, which I'm going to talk about. But at the same time, these kinds of community identity building can also give rise to collusion bidding. And we really don't know what's going to happen because there is not much literature on this. So that is why we were interested in implementing these two treatments. So what do we do in this particular study? We consider a new auction in which both winners and losers, losing bidders, they receive payments. Winners receive payments equal to the value of their bid, which has been selected by the auctioneer. And they receive a payment which is equal to, and I want to say this properly, they receive a proportion of the remaining budget. And losers do not receive their bids because their bids have not been selected, but they also receive a proportion of the remaining budget. So that part is new in this particular auction, which has not been studied in any other conservation auction setting, okay, which brings in this utilization rebate feature, if you will, because that remaining budget that is left over after paying for all selected bids is equally divided between all participants in the auction. Okay, so then moving on, what does our experiment look like? So we had a fixed group of 8 participants who participated in our auctions, and we collected data for 192 subjects in total. Each subject was endowed with one project for which they had to submit a bid to the auctioneer. And this project had a cost and a benefit, environmental benefit associated with it, which were drawn from these uniform distributions. And we drew these parameters in a way that there is minimal correlation between the costs and benefits for each project, if you will. The auctioneer has a set budget of 3250 experimental currency units, and this was not announced to participants following findings in the existing literature. Okay, so what are our treatments? We consider a combination of between subject and within subject designs as indicated by the table on your screen. So we considered an auction format. So the auction format treatment involved 8 sessions each of 3 types of auctions. So the current auction, which does not have this utilization feature, and the new auction, which has this utilization feature, and a prime auction, where we marry this utilization feature with a priming task, which primes group identity, okay? In the information treatment, which was a within subject treatment, in some periods of the auction, information about environmental benefits of the projects was not provided. to the participants, and in other sessions, other periods, the information was provided. This gave rise to 6 auction treatments, which is presented on the screen for you. We also looked at 4 types of cost benefit parameters, and we assigned those cost benefit parameters in a way that there would be no other effects. And in the absence of asymmetric information, if the auctioneer was procuring projects, then every person in the auction could win 8 times. Our session lasted for no more than 2 hours and had 16 periods with the same budget. The information treatment change was implemented at period 9 for each session. So the first 8 periods, you either had information about benefits or you did not have it. And similarly, the converse condition held for the remaining 8 periods. In terms of winner determination, a very, very simple winner determination rule, which is that once all bids were submitted, a scoring metric was computed, which is a very simple benefit cost ratio, and all bids for all projects were ranked in descending order, and projects were selected till no other projects could be procured. Then whatever was left, that amount was doubled and redistributed to equally to everybody in the auction, in the game. So that is the new utilization budget, if you will, feature that we implemented in the new auction and in the prime auction. So I've got 1 more minute, but hopefully I'll be able to breeze through the results. These are the 5 stages of the experiment where we started with the risk elicitation stage, and this is the no prime, no info treatment. Then we had the priming activity, a practice auction, and then the different periods of the actual auction, after which we had a demographic survey. So these are our 3 auction performance metrics. First of all, we looked at the proportion of environmental benefits, which is the benefits realized in the auction, followed divided by the total amount of benefit that is possible without asymmetric information. Then we looked at the benefits generated per unit of expenditure. And this expenditure, this value was scaled up for the current auction or the baseline auction setting where there is no utilization feature, so that we could make comparisons. And we also looked at the number of auction winners. So some summary statistics for you. What we find here for our 3 metrics of performance is that as you go from the current status quo auction to the new auction, proportion of environmental benefits increase, benefits per unit auction expenditure, which is our metric of cost effectiveness, increases, auction and the total amount of number of winners that are selected increases. But when you go from new auction to the prime auction, then you see that there is a reduction in the magnitude of all of these performance metrics, which was actually pretty interesting to us because that is not what we were expecting. We find a similar outcome for the conditions where environmental benefits were actually revealed. So I have for you over here the different regression analysis, random effects regression analysis, comparing the current auction to the new auction and the new auction to the prime auction. And what we find over here is that as a result of the utilization feature, cost effectiveness of the auction goes up. The p-value for this is 0.052. So we miss statistical significance at 5% by a smidgen. And that's another reason for actually noting the p-value there, because you don't want to underpromise as well as overpromise on the significance over here. What we also find is that information has no impact in the baseline auction, but it actually reduces performance in the new auction when comparing it to the baseline auction. And also we find that experience in the auction improves auction outcomes for both the new auction as well as the baseline auction. When we look at the priming effect, we can see I've run out of time, but that's all right. My main over here, we see that our main finding over here is that this new auction mechanism, won't go through the other metrics. this is my last slide. So the conclusions is that, this utilization feature that we implemented in our auction works in terms of improving the performance along multiple dimensions. And priming for group identity, however, lowers auction performance across all of these dimensions. Okay, so benefit information has no impact on performance of current auction and reduces the performance of both the new auction formats. So we are, again, as I said, this is very, very preliminary. So there's a lot of ongoing analysis that we need to do. We need to look at other specifications for the total winners regression model. We want to do bidding behavior analysis to see what's driving these differences in behaviors. And we want to look at the analysis of bidding and auction performance at the point where the information treatment switches. And we also want to look at the priming treatments and look at what went on in those treatments to cause the differences in effects that we see. So with that point, that brings me to the end of my presentation. Thank you very much for your attention to this. I'm happy to take questions.
Thank you, Shmanti. We do have time for a question or two, if there are any. And again, if you're willing to run up really quick and ask it, that would be awesome. Kent, do you have it? Or I can, yeah, just so that it's communicated as clearly as possible.
Hey, Shmanti.
Hello.
Quick question for you here. So I love the idea of using the budget remainders and making it more efficient. I mean, obviously those budget remainders can be quite large at some points, depending on the size of each acquisition, right? So if you're talking about full fee acquisition, you could have really large, lumpy, expensive things. If we were just doing, easements or small conservation practices, maybe the cost would be lower. So there seems to be a lot of variability into how much money that would be left for this. And I don't know enough about your design. I mean, it seems like one of the good things is you're trying to help deal with the problem with auctions, which is we get less bids than we should, right? And so you're trying to reward those that are losers to at least come away with something. And I wonder, to what degree, if we just offered them, a chunk of money, several $100s, that would be better, or having this uncertainty, of a big windfall, perhaps if it's really lumpy or not. So just thoughts, comments on that, and I'll shut up.
No, I think I think you had two comments. One is about how much money is left over, and I have that variable computed, but I've not analyzed it and looked at it. So I will definitely go and look at, did we see wide variations in that amount of money? Because you're right, depending upon the kind of, procurement we are looking at, those funds can be substantial. So in that sense, that point is very well taken. The other point about, whether, paying lump sum amounts is better than, having producers go through this uncertainty. And, you have me there largely because of the fact that in talking to other people who have worked with field data or survey data on these auctions, producers don't want to participate in this because it's just so complicated. So in that sense, maybe having them, making lump sum payments to them might be better than having them go through this uncertainty of bidding, which involves both pecuniary transaction costs as well as cognitive transaction costs, and then say that, hey, this is the amount which we can give to them anyways. Having said that, in talking to producers in Nebraska and enough extension folks in Nebraska, my sense is that producers like money like anybody else, but they don't want to just get it for the sake of it. They want to work for it as well. At least many of them do. So in that sense, that could be a way to motivate why we want people to go through this, kind of exercise in uncertainty to get these payments, which in any way we could give to them as a lump sum transfer. So those are the thoughts that I'm having, but great points. And thank you so much for those comments.
Thanks, Shmanti. And we should have a few minutes at the end for questions.
Absolutely.
But for the sake of time, we're going to move on to our next speaker.
Great.
So I'm going to go ahead and share screen.
Yeah, my screen is unshared. Okay, great.
Yep, I took yours off.
Thank you so much.
Just give me, yes, thank you. So Shmonti and Leo, please confirm that you can see the screen.
We can.
Okay, wonderful. So our next speaker is Tongsi Lee from the University of Guelph.
Thanks, Leah. Thanks, Shimani, for organizing this session as well. Good afternoon. My name is Tongsi Lee. I'm at the University of Guelph. For those of you who might not know where that is, it's very close to Toronto, very nice place. And really glad to be here presenting this work co-authored with Dr. Leah Foster. And what we're going to talk about today is, can transaction cost subsidies increase cost effectiveness of conservation auctions? And we are going to present a randomized controlled trial in this case. Okay. For those of you who might not be really familiar with conservation auctions, okay, the reason why we're using this mechanism now more and more these days is because we want to create incentives to enhance the provision of ecosystem services in agricultural landscapes. So what that essentially means is in these PES programs, buyers, often government agencies or environmental organizations, would offer financial incentives to providers who are usually farmers or agricultural producers that take actions to generate ecosystem services beyond the status quo. And specifically talking about reverse auctions, how does it work, right? So bidders who are farmers usually are going to submit some bids. So those are their willingness to accept, meaning that they would have to get compensation in that amount in order to perform some actions, okay, that are good for the environment. And you can probably see that farmers or farm characteristics can contribute a lot to people's willingness to accept, or in this case, their bid. And there's a part which Shimani Shimani included in her presentation. So there's also practice evaluation, right? Meaning that different bidders might have different environmental benefits on their land. And then sometimes for a lot of reasons, in some auctions, we actually don't consider this part, meaning that we call this homogeneous evaluation on different lands. And then what essentially happens after everybody submits their bid is the program manager would then rank the bid, right? And they value the marginal benefit and marginal cost, and they fund a number of projects. Okay, so now let me move on to the specific program setup in our RCT. Okay, so in this randomized control trial, we assume homogeneous expected benefits, meaning that the bid selection is based on the rank of bid alone. Okay, so we are assuming that every single land is going to provide the same amount of ecosystem services if they are adopting the same practices. Okay, and then so the least costly project is then ranked first, and the most expensive project is going to be ranked last. Okay, so that's just the at the high level, the setup. And we are running a discriminatory price auction, meaning that winners will get exactly how much they bid, okay, instead of having a cutoff price for everyone. And this is a budget constrained auction, meaning that bids are going to be accepted in ranked order until the budget is exhausted. Okay, so let me then motivate this randomized control trial. So how did this all begin? In 2021, around summertime, the Ecological Farmers Association of Ontario, so EFAO, gave me a call, and they asked me, look, we have this small budget, which is $65,000 this year, and we would like to encourage farmers to grow small grains on their farm. Okay, so they want to encourage diverse crop rotation. And their question to me at the time was, would $40 per acre be a good number? My answer to them, just like my answer to almost all the questions in my life, is I don't know. So what I did tell them then is, you know, I don't know if $40 per acre is a good number, but at the same time, it seems reasonable. Have you considered there is such a thing called reverse auction? And in economic theory, it's very rigorous, right? It's going to actually solve a lot of problems because you are asking people to tell you how much they want instead of assuming how much you have to pay them. And amazingly, everybody was on board. And they were like, you know what? It's probably going to be too late for this round, but there's going to be another round. Let's try it out. So the really nice thing about this is they had run this flat payment or fixed payment program for fall 2021. And then they adopted the idea of a reverse auction for spring 2022. So not only can we actually take a look into how reverse auctions perform in the field, but we can also benchmark it towards the fixed payment program they run in the previous season. So let me then go through these numbers and this we left graphs, right? So if you look at the horizontal line here, right, which is the fixed payment program EFL run, so they paid each successful applicant $40 per acre, and with their budget of $65,000, what it means is they can fund 1,625 acres in total, assuming enough people submit their application. But no matter how many people submit their application, as long as they meet the threshold. Okay, so that's essentially the blue area in this graph. And in a dream world, if we get every single farmer to submit their bid to let us know how much we need to pay them for them to adopt the practice, then you're looking at this the curve on the rightmost side. Okay, so if we have the supply or the bid from all farmers, then you rank the bid from the lowest to the highest, and you fund everyone until you exhaust your budget, meaning that you are going to be able to fund a lot of acreage in this case, right? So in reality, before we run this randomized control trial, we knew that usually you don't have all the farmers to submit their bids. So you have the supply or the bids from some farmers, okay? And in that case, if you see a lower amount of bidders compared to the entire population, you will see sort of like the purple area there, okay? And then, of course, we also know that in reality, there's rent-seeking behavior or bid shading behavior in reverse auctions, okay? So we are going to talk about mainly two things. One is, did it work in reality? Did it work this way such that a reverse auction, although it doesn't get the bids from all farmers, it outperforms the fixed payment program, okay? And the second question we are going to answer is, we did put some treatment arms. We provide half of the farmers a transaction cost subsidy, okay, and the other half without. And we also interact that with an information nudge. Okay, let's see how those work and did they improve the reverse auction. So of course, this is not an exhaustive list, but we built upon a lot of great research recently. Okay, of course, many of you are in the audience, and so if you look into the literature in the past decade, okay, there's a lot of papers talking about reverse auction performance. Okay, so there are two parts usually. One is the bid shading behavior, and how do we improve reverse auction performance by designing the mechanism and by mitigating the reverse auction bid shading. And more recently, actually, the literature has paid attention to the participation as well, right? So there are 3 papers I listed here. First was by Leah and co-authors, a simulation looking at how transaction cost change, the participation in these auctions. And then the second one I listed here is a paper based on real field reverse auctions, meaning suggesting that a lot of them had lower than 2% participation rate. And then the last one listed here is by myself and co-authors, a working paper in the lab. Okay, we use a laboratory experiment to look at how transaction costs change participation. And the punchline from this laboratory experiment is that, consistent with economic theory, okay, when transaction costs are lower, the participation rate is higher. However, through a simulation, we also found out that transaction cost subsidies are costly to program managers. Therefore, they do not necessarily increase the auction's cost efficiency if you consider both sides. Okay. So with that in mind, we then bring things to the field. And this is our design. This is our treatment table. Okay, we have 2 dimensions. One is the transaction cost subsidy, and the other is the information nudge. Okay, the information nudge was designed by the EFAO using their outreach program, and the transaction cost subsidy was randomized at the county level. Reason being, we don't want farmers to talk to their family and neighbors at Christmas party and then cross-contaminate. So so two dimensions for treatments in total, treatment groups in total. And then just as some notes, okay, the cost effectiveness of this reverse auction will also be benchmarked towards the previous flat rate cost share program launched by the same organization, same program in actually 2021. Yeah. Okay, and in total, more than 3,000 emails were sent to farmers from 24 counties in Ontario in December 2021 and January 2022. Okay, and we pre-registered the randomized control trial OSF. Okay, excited about the results? I'm going to go back to the graph that we loved, right? Okay, what happened? Take a moment to, I think everybody can read this, right? So as opposed to what we assumed, not many farmers are going to bid, but a decent amount of farmers are going to bid, and then people are going to have some bid shading, but then how bad can that be, right? This red line is what happened to us in 2022. So what happened there is, if you compare this reverse auction bids to the previous fixed payment program, only 7 people bid lower than 40. In the fixed payment program, 68 or 69 people submitted their applications to the program. So what is going on, right? We've got to ask ourselves that question. Again, the answer is probably, I don't know yet, but let's see what we can do here. And in total, when we ranked the bids from the lowest to the highest, we were able to fund slightly less than 1,000 acres. Okay, so that is actually lower than the previous year when we used fixed payment mechanism. So the real question here is, did we fail? Is it worth it? How do we move forward? Okay, so just put things in summary, right? Basically what I talked about, only 7 participants bid lower than $40 per acre, which is the benchmark, right? If 69 people submitted their application when we were paying them $40 per acre, it should be at least that number of people who are going to actually submit, right? Because now we don't have any constraint. They can go over 40, and probably 69 people should bid under 40 if there's no bid shading, right? Okay. And then, well, of course, the break-even budget in this case, had we run the flat payment, is going to require a lower amount of money compared to what we used in the reverse auction. So is it worth it? Okay. What's really, really exciting going forward is we are going to be able to answer a few questions. Who participated, and is there any heterogeneous behavior among participants? Can we do a more targeted design going forward in the future? And the second question, again, is there any way to improve? And I love how people outside of academia perceive things in very, very different ways. The one thing that EFL was super excited about, I never thought it would happen, was they told me, we love it, because we didn't have to reject 80% of the people for no reason, which happened in the flat payment program, right? And also because we ranked their bids objectively, we were able to collect some data, some demographic data, which I'm going to show you, okay? So of course, these analyses are still preliminary, but, okay? So who participated? Is there any diversity? So it's really interesting, right? Well, we know that about 90% of the farmers are men, but in our sample, it's about 65%. Okay, we see a decent amount of women who participated, and there's one person said they were two-spirit, and one person said they prefer not to answer. But if you compare who participated, 37 people submit their bid. But the total response we got was 34. You know that 3 people really showed us they prefer not to answer. Okay. Now, what's even more interesting, let's look at the last row here. In this case, when we asked them about do they belong to any minority groups, well, really 10 people showed us, revealed their preference that they don't want to answer. But then again, you see a decent amount of diversity in our participant pool, right? Only 60% said they are none of the below among the people who answered. Okay. All right, and then when we asked them about their organic practice, everybody answered, and we do see diversity there. Okay, so let me jump into the 2 regression slides that I have. Okay, the first one is it reports the marginal effect from a logit model, and what we saw here is the transaction cost offset did not change participation rate, and the magnitude is so small that I would doubt had we had higher statistical power, what would happen? Okay, so but the nudge did change it, did increase the participation, and being an EFL member instead of just random farmer in another database improved the participation rate. Okay, and then so if we look at, is there any heterogeneous bidding behavior? From this slide, because the sample size is still low in this what we call a pilot reverse auction, but one variable that really stands out is being a majority, meaning that I don't belong to any of the categories and I am a man, dramatically decreased the success rate. And remember, it's all objective, so this is solely due to their relatively higher bid. Okay, and then I think that's a particularly interesting preliminary result that we're looking into. And this is my last slide. There's lagging, so that's why it's a little bit weird. Okay. Okay, wonderful. So let me conclude by saying what's next, right? We are actually really lucky because EFL is fully on board, and they are committed to a series of reverse auctions in the next 4 years. And we will have 8 different calls going forward. We are going to work with them closely to look at the participation rate. Maybe we'll reach out to more farmers. Maybe we'll change our auction design and do a more targeted mechanism design and through education. And then on the bid shading behavior, we are going to, again, try to improve our auction design and then test out how different information messages and messengers change people's behavior. Okay. And with that, I will conclude. Thank you.
Questions. First, I will ask about information that you provided in your information as to what type of information you are. And the second question is like you said that you sent out emails to 24 different counties. So did you observe any kind of a bidding difference in these counties? Like whether, for example, you said that the range in one county is kind of similar, that everyone bidded in the same range than the other counties, because there might be a chance that these farmers are interacting with each other and they might have discussed about these conversion practices or something. So they might have bidded in the same range.
Yeah, thanks. So quick answer back to the first question. The information nudge we sent out was basically, crop rotation helps, mitigate soil erosion, so on and so forth. Very standard outreach material designed by the FAO. The second question, it's a great question. And so the reason why we were not able to do any analysis this round is because of our sample size. And we see just scattered bids from different counties. And for some counties, there's 0. For most of them, there's 1 or 2. So in that sense, it is spread. So basically, not all bids are from one county or just 1 or 2 counties. But then at the same time, we really don't have enough statistical power to cluster by county. But going forward, we're definitely going to take a look at that. Thanks. Yeah.
For the sake of time, I think we should switch to the next presenter, but hopefully we'll have a few minutes at the end for questions. All right, so. Yeah. All right, Leo, if you can share your screen.
Yeah, thank you.
All right, so while he's getting set up, so our next presenter is Leo Liu from the University of Cambridge, and we can see your screen well.
Okay, great. Thanks, Leah. Hello, everybody. This is Leo from Cambridge Land Economy. It's a shame that I can't join the session in person, but many thanks to Semanti and Leah for organizing and for making it possible for me to join remotely. And today I'll be presenting our recent study on spatially coordinated conservation auctions, a framed field experiment focusing on farmland wildlife conservation in China. And this study is a joint effort with my co-authors from the United States, the United Kingdom, and China, including Semanti, who just talked. Okay, so in this study, we want to look at joint bidding and agglomeration bonuses in spatially coordinated conservation auctions. And this study is set in the context of land-based payments for ecosystem services, or PES. Just now, Semanti and Tongsi have talked about conservation auctions or PES auctions, and I'm sure many of you in the audience are experts in this area. So I'll just be brief about PES and PES auctions. But in this study, we are looking at a specific kind of PES, which pays farmers to switch to environmentally friendly activities to benefit wildlife living close to farmland, such as birds and bees. For example, this program might be paying farmers to switch from using chemical pesticides to biological pesticides, and we're assuming that biological pesticides could benefit wildlife living close to farmland. But biological pesticides can be more expensive than chemical pesticides. So the PS payments are meant to compensate farmers for such opportunity costs of providing the environmental good valued by the public. And just now, the 2 speakers have mentioned that PS contracts can be allocated using PS auctions or conservation auctions. These are reverse auctions where the PS program prioritize farmers who offer to provide more environmental benefits or farmers who ask for lower payments or both. And in this study, we look at a particular kind of PS auction, which facilitates spatially coordinated conservation or contiguous conservation. The rationale for promoting contiguous conservation in our context is that many species benefit more from environmentally friendly activities on multiple farms next to each other. compared to the same activities on the same number of farms that disconnect from each other. For example, if one farm switches to using biological pesticides, but the neighboring farm still uses chemical pesticides, because animals move around all the time, so birds and bees move around. So when they move to that farm, which still uses chemical pesticides, they're still likely to be poisoned. So in other words, these species can have some extra benefits from the spatial coordination of environmentally friendly agricultural practices, which we call edge benefits. And these edge benefits are relative to what we call the node benefits, which refer to the benefits of those of the wildlife from activities on each farm individually. So in the context of PES auctions, there can be a few mechanisms to promote contiguous conservation. And one mechanism is what we call spatially coordinated conservation auction. So in this kind of auction, when ranking the bids, we would account for the total environmental benefits, including both edge and node benefits. And aside from that, another mechanism is to provide agglomeration bonuses, or AB, in conservation auctions. So in this context, or in this mechanism, farmers still bid individually, but winning farmers receive a bonus payment if neighbors also win. And a third mechanism is joint bidding, or JB. So in this mechanism, neighboring farmers can choose to bid jointly for a joint PS contract. So they can either win a joint contract or no contract at all. So these are the three mechanisms in PS auctions that can facilitate the spatial coordination of conservation or environmentally friendly agricultural practices. These ideas have been promoted by PS review literature. Although when it comes to empirical evidence, because these are relatively new ideas, so they haven't been applied in a large scale. And most existing formal empirical evidence comes from experimental studies, especially laboratory experiments using university student subjects. And there have been a few lab experiments looking at spatially coordinated PS auctions, including these studies. And there are some other studies that look at non-spatially coordinated PS auctions with and without agglomeration bonuses. So these studies looked at the treatment effects of adding AB to PS auctions. It's just that these PS auctions are not spatially coordinated conservation auctions, so they don't account for edge benefits when ranking the bids. So that's how these studies differ from our study. In our study, throughout our study, we look at spatially coordinated conservation auctions. Okay, and there is one laboratory study conducted by my co-authors Simanti and Tim and Nick, which looked at joint bidding in PS auctions. And there have been some other laboratory experiments that look at joint bidding in non-PS contexts. So looking at those previous studies, we can see some research gaps. So the first one is that there hasn't been any formal statistical evidence on the performance of adding AB and or JB to spatially coordinated PS auctions. In other words, if the starting point is spatially coordinated PS auctions, can we further improve their performance by adding AB or JB? A second research gap might be that there seems to be a paucity of experiment studies using farmer subjects rather than student subjects. Of course, using student subjects in a lab environment has many benefits, such as a more controllable environment, which would be very good for rigorous testing of economic theory. But very often, when academics try to promote these ideas to policymakers, policymakers may want to see evidence drawn from real farmers in addition to evidence drawn from university students. So in this study, we seek to reduce these gaps through a framed field experiment conducted with Chinese farmers. Okay, and our experimental design is a 2x2 4 factorial design. So the starting point is a treatment SC, which refers to spatially coordinated conservation auctions without AB and without JB. And next we have a treatment SC-AB, which has AB but not JB. And then we have treatment SC-JB, which allows joint bidding but doesn't provide agglomeration bonus. And lastly, we have treatment SC-AB-JB, which has both joint bidding and agglomeration bonus. So starting from treatment SC, or the basic version of the spatially coordinated conservation auction without AB or JB. So the auction is a hypothetical auction game involving real payments. So participating farmers were not signing any real PS contracts, but what they do in the auction game would affect how much they earn from participating in the game. And farmers bid in groups of 6, assuming each of them owns one of the 6 farms on the circle, as shown in this graph. We assume that all these farmers use the farms to grow fruit trees. And this hypothetical PS program pays enrolled farmers for switching from chemical to biological pesticides to benefit birds and other farmland wildlife. And we ask each farmer I to bid for a PS payment BI, which would make them willing to switch from chemical to biological pesticides. If farmer I wins the auction, he or she enters a PS contract and receive a payment equal to the amount he or she has bid, which is BI. And he or she bears a cost CI for switching to biopesticides. So in the treatment SC without AB or JB, the net payment of farmer I winning the auction would be the difference between the two. And the environmental benefit produced from farm I depends on whether farmer I wins the auction, and also on whether the neighbors also win the auction. So here we have the node benefit, and here we have the edge benefit. And the total environmental benefit would include both parts. On the other hand, if farmer I doesn't win the auction, he or she will not receive a PS contract, and he or she receives 0 net payoff from the auction. And the winners are selected in such a way that maximizes the total environmental benefit under a fixed budget constraint. And this total environmental benefit includes both node and edge benefits, as we just mentioned. So this is how we designed spatially coordinated conservation auctions into our experiment. Okay, I don't think we have time to go through every details of procedures of the experiment, so I'll just briefly talk about the procedures. So briefly speaking, each auction group do 3 auction periods, and each auction period is a new auction where the results are decided and the parameters are reassigned. And the parameters include the cost and benefit parameters for conservation. And in each auction period, there are multiple bidding rounds ranging from 3 to 6. And the final round's results are the results of that period. Okay, so that's the treatment SC, or the basic version of the spatially coordinated conservation auction without AB or JB. Then we add agglomeration bonuses to that baseline treatment. So in this treatment, each farmer still bids individually. But if farmer I wins the auction, and if at least one neighbor also wins the auction, then farmer I receives a bonus payment equal to the edge benefit. So now the net payoff function for farmer I can be expressed like this. So now the net payoff received by farmer I depends on not only whether farmer I wins the auction, which is indicated by this binary variable Wi, which equals to 1 if farmer I wins the auction and 0 otherwise, but also depends on whether the left neighbor or the right neighbor also wins the auction. So that's a key difference of this treatment compared to treatment SC. So basically, we are introducing the agglomeration bonus mechanism into the spatially coordinated conservation auction. All the other rules are the same as in treatment SC. So next, we introduce joint bidding. So in the treatment SCJB, each farmer I is allowed to bid either individually or jointly with one or both neighbors. In this treatment, we still provide a bonus payment for farmers who win the auction through a joint bid. And the rationale is that on the one hand, if a farmer enters a joint PS contract with 1 or 2 neighbors, then this joint PS contract is bound to provide edge benefits, which should be paid for. And on the other hand, we assume there might be higher transaction costs for farmers to coordinate a joint bid, which should be covered. So that's why we are providing a bonus payment in the JB mechanism, which we call a joint bidding bonus. So now the net payoff of farmer I looks like this. So again, this depends on whether farmer I wins the auction and whether farmer I wins the auction through a joint bid with one or both neighbors. And still other rules are the same as in the baseline treatment. So in the final treatment SC, AB, and JB, we have both the AB and JB mechanisms. So now the net payoff function looks like this. It's just for the same neighbor, farmer I could only potentially get either a joint bidding bonus or agglomeration bonus, because with the same neighbor, they could only sell their land once, either through an individual bid or through a joint bid. Okay, that's the design of our experiment. We did our formal field work last summer in China. So altogether, we had 72 auction groups consisting of some 400 farmers. And okay, thank you. And these auction groups were randomly assigned to one of the 4 treatments, as we just mentioned. The fieldwork took place in Huangshan municipality, which is a beautiful landscape conservation site in China. And we did the experiments face-to-face in a paper and pen style. Okay, as we mentioned at the beginning of the presentation, and the primary research question is about the treatment effects of the AB and JB mechanisms. So these effects were estimated at the auction group level using both parametric and non-parametric methods. And the p-values were corrected for multi-hypothesis testing because we are looking at 6 outcome variables that indicate the performance of auctions, including environmental benefits and cost effectiveness. So if we compare SC, AB, and SC, we can see that after adding agglomeration bonuses, the environmental benefits are similar. There is no statistically significant difference in these 2 environmental benefit indicators. But adding AB leads to higher costs and lower cost effectiveness. If we compare SCJB and SC, we can see that adding the joint bidding mechanism leads to lower environmental benefits, lower bids, and fewer winners, as we can see from the results here. Okay, lastly, if we add both mechanisms, as we can see from the results here, this would lead to lower bids than the baseline treatment, but this new treatment would be outperformed by a treatment SC in all other indicators, namely lower environmental benefits, higher costs, and lower cost effectiveness. Okay, so it seems that we don't have positive evidence about whether adding AB or JB can further improve the performance of spatially coordinated conservation auctions. And the main reason is that when we provide an agglomeration bonus or joint bidding bonus, farmers tend to bid lower in light of the bonus payments. But the reduction in the bids is still lower than the size of the bonus payment. So the total payment in these two treatments is still higher than that in the baseline treatment, where the bonus payments are not provided. In other words, it becomes more expensive to bring those farms into the PS program. And therefore, in the AB and JB treatments, fewer farms are brought into the PS program, and therefore the environmental benefits become lower. Okay, after that, we also looked at some factors which could potentially affect farmers' bidding behavior, including how much to bid and whether to bid jointly. Okay, thank you. I'm finishing soon. So a farmer is likely to bid lower under these conditions. For example, if AB is provided, if the farmer chooses to bid jointly. So these results show that farmers do indeed bid lower in the AB and JB mechanisms. And there are some other conditions which could lead to lower bids. And also in terms of whether to bid jointly rather than individually, we found that a farmer is more likely to bid jointly if AB is not provided, and if the conservation activity could generate higher edge benefits, and if this is a farmer's first auction period, and so on and so forth. This one's quite interesting. If this farmer has real life agricultural collaboration experiences with at least one neighbor. And here we have the covariance balance test, which looks quite good. Okay, so those are the results we have so far. As we mentioned at the beginning, so this is the first framed field experiment on whether the performance of SCPS auctions can be further improved by the introduction of AB and JB. Of course, our results didn't find supporting evidence for this hypothesis, but we did find that farmers tend to bid lower in the AB and JB treatments. Okay, that's all of my presentation. Any comments or questions would be very welcome. Thank you.
Great, thanks, Leo. Any questions from the audience, or Shmanti, if you have a question, you can unmute yourself as well, of course.
I'm good, thank you.
So to Leah, I was thinking it's really interesting that you're finding these results in the lab in terms of the joint bidding behavior. If I understood correctly, although they're bidding lower, it was still outperformed, right, by the spatially coordinated auction. I was just wondering if you talked to those farmers any, like in a focus group type setting or any type of informal setting after the experiment, to know if it was outside of kind of the framed field experiment setting, how they felt about the joint bidding. And the reason I ask is just from a little bit of experience trying out a joint bidding setting in a framed field experiment during my PhD. And I had farmers saying like, yeah, it's fine here, but I don't think we would do this. And I was wondering if you had any similar feedback.
Do you mean whether those farmers indeed tried to bid jointly during the experiment, or whether they would do that if this was a real PS program?
Right. Like, because in the real PSC program, presumably they would be somehow accountable for the other farmer that they were bidding with and their behavior and making sure they abided by the rules, etc.
Yeah, I see. Sorry, we didn't talk to farmers about that, but that sounds quite relevant. And we did find that farmers are more keen to bid jointly if they had real life collaboration experiences with their neighbors. And so maybe that could be somewhat relevant to the point you just mentioned. So maybe those farmers know each other better through previous collaboration experiences. But it's a shame that we didn't ask them about whether they would do that in a real PS program.
Yeah, I think so. That result that you presented on one of the last slides caught my attention, because I also felt that was really relevant to moving this from kind of a framed setting into the actual fully incentivized version of the field experiment.
Yeah, I think so. I guess this could help policymakers to get a general expectation about which farmers are more likely to bid jointly, because obviously in some kinds of agricultural production, there could be more agricultural collaboration, and in some other cases there could be less. So that might be relevant.
Yeah, absolutely. Okay, well, we'll hold additional questions if we have some work pop up. We'll hold for the end of the session. But right now, I'd like to introduce our fourth and final speaker. So we have Lucy Shia from the University of Delaware, and I'm going to share her screen. So you, Leo and Shamanti, you should be able to see that. If not, yell at me. There you go.
Interesting. Oh, the color looks a little different, but I think I can handle that. Thanks to Monty for organizing this session, and thanks all of you to stay at the end. And it's my pleasure to share a study that I did over the past year. And it's interesting that this talk is at the end of this session because it shares a lot of similarity elements with all the three talks above. It has the lab experiment, it has field experiment, it has reverse auction, and it also has animals. And so I'm going to talk about a study that fights back irrigation water for endangered species protection using lab and field experiments. And this is a joint work with my co-authors. Two of them are here, Leah Pong-Forster and Ken Messer, and Mark Marster and Holly Michael. And I'm going to start. Oops. Let's see if it's moving. It's not really moving. Okay, there you go. Okay, so the very big motivation of this study is that water shortage has become a very serious global problem. With the increase, the population growth, there is an increasing demand of water. And as a result, we have seen more and more unsustainable pumping. And also that also goes to the very serious conflicts among water users. As you can see that the graph on the top, that the irrigation and thermoelectric power are the two biggest water withdrawal as of 2015. That's the most recent data I can find. And so we can see that because of those conflicts and water shortage, and even more, the climate change has made it even worse because higher temperature reduces the supply of water. Just a lot of water has not, like rainfall or snow didn't get a chance to become water before they already evaporated. And severe droughts, of course, increase the demand for water. And like from the most recent U.S. drought monitor, you can see that more than half of the region in the United States are experiencing either the exceptional drought, extreme drought, or severe drought, which is very anxious to make me very anxious. And go to the next slide. Okay. So farmers and wildlife are really struggling during the drought, especially because of the water shortage. For farmers, they heavily rely on irrigation water to grow crops. But with the drought, the crops need more water. And with the water shortage, farmers do not have enough water for irrigation, so that they have to either reduce or stop the original cropping plants, or they have to switch to a more less water intensive crops. And wildlife, on the other hand, they are like us. They need to drink water to survive. But unfortunately, they cannot adapt as quickly as our human being. From the quotes that's from the USGS, you can see that reduced water availability is one of the causes that increase the risk of decline of those endangered species, especially the aquatic species. Okay, so the question will be, how do we want to solve these problems? And unfortunately, there is no universal and effective solutions to the water shortage. And we have seen some water use restrictions especially for household water use. And this is the picture I took on my way here, just ask people to reduce their outdoor watering. And there are some discussions on water pricing, but I don't think there is a really well-established water market to regulate that to solve this issue. So for irrigation water, one solution is the water buyback programs. And in those programs, government agency buys water extraction rights from farmers to reduce irrigation. And most of those programs use the posted price mechanism, which is take it or leave it. And we have seen those programs in the United States and Australia. But interestingly, most of the discussion of the cost effectiveness of those programs uses either simulation or dynamic optimization. And we have not seen many evidence, experimental evidence on whether those programs are cost effective. And so if you look at the setup of those programs, it's a natural fit for reverse auction. And thanks for the previous speakers, we already know a lot about the auction, and then we know there have been a large development on the literature about how the reverse auction for land conservation. And interestingly, we have not seen like those lessons being transferred to water conservation. And to the best of our knowledge, I think there is one water buyback program that uses a reverse auction that's in the state of Georgia, and it has been implemented since 2001. But over the past 21 years, we have done a lot about reverse auction. We have more data about water usage. So, but then it gives us more opportunities to try to examine this kind of setup. And that comes to the objective of this paper is to examine the cost effectiveness of the alternative auction mechanisms to inform the implementation of a water buyback program for species conservation in Georgia. And we, based on the seminal work by Cummins et al. To design the reverse auction. And we implemented that with the lab experiments with students and also field experiments with farmers. So this paper makes several contributions. And the first one is we examine the cost effectiveness of reverse auction for buying irrigation water, whereas most of the literature on the reverse auction is on the land conservation, and most of the water buyback programs do not use reverse auction. Second one, we show like a path to go from lab experiment to field experiment and a high stakes field experiment and to inform program implementation. So keep in mind that this field experiment is quite expensive for farmers and for buyer, and we have not seen a lot of those type of experiments in developed countries. And third one, we demonstrate a way of linking policy-based evidence and evidence-based policy. What does it mean? It's basically, we already know there is a water buyback program in place, but we know there's a need to change it, so that we designed this study to provide evidence. And with our evidence, we can show the policymakers how to better design the policy. Okay. So before I talk about the experiments, let me introduce the study area, because it's pretty important for as the background. So we are looking at a place called Otway Creek Basin. It's in Southwest Georgia, and it is the main tributary of the Flint River in Oregon. And there are 4 endangered freshwater mussels. Let's talk about agriculture. So this is a close-up map for the Otway Basin, and it is at the center of Southwest Georgia agriculture economy. And farmers have widely adopted very efficient irrigation practices and equipment. And we have really good meter data because that's from their amount to monitor their water use. And farmers use surface water and groundwater for irrigation. The surface water are the red dots, and groundwater are the green dots. Unfortunately, the stream flows have dropped to extremely low levels during the drought. As you can see from the graph, it's dropping kind of linearly. And this one is a little hard to see, but they are like about 7 times that the stream flow were extremely low during severe drought. And so most of those droughts were during the summer. And so with very low stream flow, endangered species are at a higher risk. And according to the hydrological ecological models, the potential solution to increase stream flow for species conservation is modest reduction in irrigation withdrawals during severe droughts. And so that's how the Flint River Drought Act has started, and it's actually it is the current water buyback program in the state of Georgia since 2001. And so some background on this program. So it is a reverse auction, but it's only implemented if there's a drought being declared on March the 1st, which was pretty early. And then it uses a discriminatory price auction and with no revisions. And it combines budget and target constraints in a way that the auction will accept offers until either the budget is exhausted or the target is met. And in this program, the auction target is acres of land to stop irrigation because it's pretty easy to monitor. And for farmers, they need to make 2 decisions on their parcels, whether to submit an offer and how much to ask the price of their offer. However, this program has a couple of drawbacks. First one, they use acre as a target, but the objective of this program is to buy stream flow. So it's less accurate in measuring environmental benefits. Second, it does not use any meter data and hydrological models. So we don't, as a result, less valuable water is bought from the program. And third one is March 1st is pretty early for to declare droughts for the state of Georgia. And so this program is less flexible. And based on that, when the irrigation is completely suspended on the winning parcel, that just means even though there's no drought, in reality, farmers may lose a lot of profits just because of this program. Okay. And then so our lab experiment design is very similar to the current water buyback program, except participants were randomly assigned to large or small farms with 3 major crops: cotton, corn, or peanuts. And in order to capture the their earnings from growing crops, their earnings consist of farm earnings and auction earnings. And since these lab experiments are designed to inform field experiments, we parameterize the farm earnings to capture the agricultural productivity associated with irrigation. And we also use hydrological models for stream flow and to capture that. So the treatments, it's 2x4 treatments, and half of the treatments use acre as the target, and another half use stream flow as the target, which is pretty straightforward, hopefully for now. And the focus of another focus is to see how the irrigation suspension will affect the cost effectiveness of the auction. So full suspension just means irrigation is completely suspended on selected parcels. And partial suspension is the irrigation is only partially suspended on selected parcels. And standby is interesting in the way that only if there is a drought, irrigation is suspended, and auction pays participants for suspension irrigation. We also add that bonus payment to offset transaction costs just because it has been found it will help increase participation. So here are some results from the lab experiments, and our main outcome variable is the stream flow per dollar. Basically, it's the cost effectiveness. And so from the graph, you can see that the yellow bars are the cost effectiveness with the stream flow target. And it's very striking that we can see that stream flow target is more cost effective. And also but the participation and offer or parcel earnings between the 2 types of targets are pretty similar. So let's look at the auction, the irrigation suspension. We see that full suspension is more cost effective than the other two, which is a little bit surprising. But we look at the parcel level data, we find out that rent seeking in the partial suspension and standby more, and the partial earnings are higher compared to the full suspension. For the adding that bonus may increase the cost effectiveness if we don't include the bonus in the total payment, but these two are not significantly different. Now let's go to field experiments. So it's very similar to lab experiments, but it's a very simplified setup because we want farmers to participate to understand. So farmers make one-shot high-stakes decisions, and we only use stream flow targets, and we also provide stream flow impact information to farmers when they are making decisions. So they provide their farm information, and then they make decisions, and then they answer the questionnaire. So the treatments are only focused on the irrigation suspension, which is full, partial, or standby. And we only randomly selected one for implementation, which was the standby. Okay, so here are some implementation details. The one I want to highlight is that we have about 50% of eligible farmers participate in this experiment, which is amazing. Just because you can see our co-author, Mark Masters, he is a great person for making videos and getting people to participate. And the high stake here, you can see that the total payment is 31K for standby because we have not triggered the threshold to for irrigation suspension, so that is kind of cheaper at this point. But if the stream flow is below the threshold, then the auction will get really expensive. So for field experiments, we focus only on the parcel level data just because we don't have multiple groups to calculate cost effectiveness. So for here, you can see that offer per acre is significantly affected by crops. And the average offer is pretty high. It's around like $1,000. And the contract full and standby offers are pretty similar. But offer per acre is not significantly affected by the stream flow impact. Just my assumption is that farmers do not have a really good knowledge or understanding of how the stream flow affects their offer, but the opportunity cost of bidding is affected by the crops. So, so we also did kind of some hypothetical selected offers for contracts, and we have some results, qualitative results. So if a drought is certain in March, then we know the full suspension is the most cost effective, and the partial suspension is the least cost effective. Thanks, Leah. And if the drought is not certain, then the standby gives us some flexibility based on the stream flow thresholds. Like this year, we have not paid out that. Okay, here is some conclusions and implications. Basically, we know that stream flow target is most cost effective, and full suspension is most cost effective, but it reduces the parcel earnings. And standby provides more flexibility based on the stream flow threshold. And here are some limitations and next steps. And thank you for your attention.
Questions, and if Leo and Shamanti have questions, you guys just feel free to unmute yourself. I'm gonna change the view so we can see you.
I have a question for Lucy. So thank you so much for the presentation, Lucy. So I was wondering, you talk about the high stakes part of your experiment. So can you give us a little bit of a motivation for why you did that? Why is that part of, what's the value in looking at having that component in your experiment, the high stakes?
So let me repeat your question is why I chose to do that high stakes experiment. So if you look at the current, most of the other water buyback programs, water is expensive. If I recall correctly, in California, the average price per acre is about like $800 to $900 for water. So like essentially it's high stake. And I think so we are using the reverse auction to understand the price of those water. I think it's just more interested in a way that we want to see how it's more costly or less costly for farmers to stop irrigation.
Thank you. I have another question, but I can wait for others to ask questions.
Oh, you can go for it.
Okay, so one other thing that you said, and I completely understand about, the constraints that we as researchers face when we look at we are looking at running a study. But one thing that you said is that, in the area, if I remember correctly, the area where you looked at, producers are pretty good with using they're pretty efficient at their water use. Is that correct?
It is true.
Right. So was there a reason for having a buyback program in an area where people are already efficient about their water use? You see what I'm saying? Like, doesn't it mean that if it's efficient, there is not that big of a problem than there is maybe, say, in California out west? Does that make sense?
Yeah, that's a great question. So it's true that they use water more efficiently, and the drought problem is less severe than places in California or that. But still, the stream flow is not the stream flow in the river is not enough if there is a severe drought. So if we start from the places that has less severe problem, and we know how to encourage people to use water more efficiently and know how to buy water when we need to do it, then it will have a real world implication for Georgia and for other places.
Great. Yeah. Awesome. Yeah, absolutely. I agree completely. Thank you so much.
Thank you.
So this has been a great session. I think we're at our time though, and I know many people in here are actually running to another session directly. So I really appreciate everyone's participation, both in person and online. And if anyone has any burning questions, we have all of our speakers, so we can stick around, but I'll formally conclude the session for those that need to run at this time. So
thank you so much, Leah.
Thank you.
Yeah, thank you all.
You tell us if we need to hang around.
It looks like we're probably good. We're going to disperse. You have a very strong UD contingent in this room right now.
And Shamanti, if you stay on, you get to see the CBER session is next in this room.
Yeah.
I see.
Oh, okay, cool. UD/Guelph.
Oh, yes, UD and Cambridge. We've got and ERS.
Yeah, of course.
Everyone, so we've kind of, I don't know if I'll stay back because the kids will be here, so I've got to go probably. I'm in Central Time and Leo probably wants to sleep.